حضورنا الكريم حياكم الله من بعد الاستراحة. نتحدث عن محاضرنا في الوصلة القادمة، السيرة الذاتية للأستاذ الدكتور عثمان محمد بكر. هو أستاذ هندسة وعلوم المواد ورئيس مختبر المواد النانوية الوظيفية، ونائب وكيل الجامعة لاستراتيجية الأبحاث في جامعة الملك عبد الله للعلوم والتقنية كوست في المملكة العربية السعودية، ومحرر مشارك في مجلة ACS Materials Letters التابعة للجمعية الكيميائية الأمريكية. حصل على درجة البكالوريوس في علوم وهندسة المواد من معهد ماساتشوستس للتقنية في الولايات المتحدة الأمريكية في عام 2003، وعلى درجتي الماجستير والدكتوراه في الفيزياء التطبيقية من جامعة هارفارد في الولايات المتحدة الأمريكية عام 2009. يقوم فريقه البحثي بدراسة توليف وتركيب مواد نانو هجين عضوية وغير عضوية ذات خواص بصرية وإلكترونية ومغناطيسية مبتكرة، والغرض من هذه الدراسات تصنيع مواد متقدمة لتكون مكونات لبناء الخلايا الشمسية والبطاريات وأجهزة نقل الإشارات والأجهزة البصرية الإلكترونية. حصل على جائزة Innovator Under 35 في العالم العربي من قبل MIT Technology Review النسخة العربية في عام 2016، وجوائز أخرى عديدة دولية صنفته التايمز أيضا دولية ومحلية، مثل جائزة الكويت من مؤسسة الكويت للتقدم العلمي في عام 22، كما صنفته التايمز للتعليم العالي كأحد الباحثين الجامعيين العشرة الرواد حول العالم في مجال خلايا البيروفسكايت الشمسية عام 2018، في حين اختارته مؤسسة كلاريفيت كأحد أكثر الباحثين المقتبس عن أبحاثهم، وذلك خلال الأعوام 2019 2020 2021 2022. فليتفضل الأستاذ الدكتور عثمان محمد بكر.
أشكر السادة الكرام جامعة الكويت ومنظمي الحفلة على دعوتي، وأتشرف أن أشارككم في المنصة مع نخبة من علماء وباحثين الكويت. الكويت بلدي الثاني، وأنا معجب جدا بثقافة الكويتيين في احتضان العلم والعلماء. اخواني، يعني المقدم اعطاكم نبذة عن النواحي التقنية من ابحاثي. اليوم ان شاء الله ساعطيكم نبذة بسيطة عن تجربتي العلمية وعن تجربتي ومسيرتي العلمية، وبعض الدروس التي ارجو من الله ان تفيدكم وتفيد الشباب في مسيرتهم البحثية. المحاضرة ستكون بالإنجليزية، لكن الأسئلة ممكن تكون بأي لغة، عدا الصينية طبعا. اسمي عثمان بكر، وكيل الجامعة الملك عبد الله للعلوم والتقنية للشؤون الاستراتيجية، وأنا أيضا بروفيسور في علم المواد والفيزياء التطبيقية. Okay, so let me tell you a bit about جامعة الملك عبد الله, King Abdullah University of Science and Technology. We're not very far from Kuwait. Actually, we're right on the Red Sea coast. Okay, and so if you're going to Mecca or Medina, please visit us. We're a few hours drive from Medina and about an hour drive from Mecca. Okay. One of the reasons why we've had some success so far at King Abdullah University of Science and Technology is because of our balance. We're a graduate university. We don't have an undergraduate program, but we focus on interdisciplinary research. So we focus on balancing research and education at the same time, and we look at balancing our international collaborations with our local collaborations. I know this conference is about sustainability, so most of the work we do at King Abdullah University of Science and Technology is about sustainable directions. about health, about digital matters, water, food, energy, and environmental matters. I think these are things that we share together with everyone in the region. We're a region that's really facing a lot of challenges in terms of environment, energy, food, but more importantly in terms of developing our human resources. You know, I'm now recruiting some of you as students, so that's why I'm giving you an overview of our university, because I hope that some of you would decide to apply and join us. By the way, we completely cover the education of PhD students and master's students. We have 3 divisions. One is focused on biological and environmental sciences, and one is focused on computer science and mathematics, and the other is focused on physical science and engineering. I'm in the material science department, but I also hold faculty positions in electrical engineering and applied physics. One of the important things that I think makes our university unique is that we have very dedicated research staff. We have 12 core labs. These labs are very large facilities that no individual faculty alone can afford, and they're staffed by professional research scientists. They cover a wide range of areas, from nanofabrication, imaging, all the way to coastal and marine resources and plant growth. We have a center directly dedicated to developing technologies for growing plants in deserts, and so on and so on. So these are very important things to support our faculty, our students, and our research. Our faculty, they're very international. We try to select faculty from all over the world. Our only main criteria is that they have to be excellent. They have to be at the top of what they're doing. So our faculty are from all over the world. We also believe that part of our strength is that our students come from all over the world. We're hoping to increase the number of students from the region more up to the 50% mark. But right now we are very international, and we hope to continue to be that way for a while, because we believe that meeting students from all over the world is part of the education of the students we bring in, of the local students we bring in. So, other than the master's and PhD degrees, we also offer talent development programs that start from all the way from middle school. We sponsor middle schools in applying in science Olympiads. We also we have programs for high school students to come on campus and do their science experiments, and many of our students end up winning prizes internationally. We also have a program for undergraduates where we send them to top universities in the world, and in exchange we ask them to come back to do some of their graduate degrees at our university. And now we've launched a recent program for our faculty development, and we take the most promising graduate students we have from all over the kingdom, and we offer them a postdoctoral fellowship at any place they wish to go to in the world. And our goal is to develop faculty, local faculty, that will be the next generation of leaders at our university. Although our university is still young, we started in 2009. We've managed to really compete on an international stage. We're still not, I mean, I'm not going to exaggerate and tell you we are at we are as good as Harvard, MIT, and these other universities we aspire to compete with. But we have some indicators that we are on the right path. So, for example, the number of percent of highly cited faculty on our campus is full-time faculty is on the same level as MIT and Harvard. In terms of rankings and publications and so forth, we compete with these top universities in many respects. But we're still not there. We still have a long way to go, and we're going to be working towards that. now I give you a bit of a background about my university and the state it's in. But actually, the reason the university has been on a good trajectory is because of the stories of the different faculty in the university. Each faculty has its own unique story of how they succeeded or how they run things. And I'd like to give you a bit of a few lessons from my own short experience in what I think worked for me. It doesn't seem obvious. It may seem obvious now, but when I actually worked and I was doing my research all those years, I didn't realize those lessons until later. The first thing is that you know يعني في البداية والنهاية النجاح بتوفيق الله طبعا ورضا الوالدين، لكن في أمور معينة يعني عوامل معينة الواحد لازم ينوه لها. So first of all, I was lucky to have brilliant students who worked with me, and really I learned more from my students than probably they learned from me. And maybe they don't know that, I don't tell them that, but that's true. And so the story of my own research success is actually a story, is based on chapters written by each one of these folks. Many of them actually have graduated. What you see is just the current lab, but there's actually maybe 3 or 4 that times that number who actually graduated from my lab. My lab is now known for their work in solar cells, for photodetectors, radiation imaging, lasers, LEDs. We develop materials for all those technologies. And our work is highly cited, well known, but actually it may seem obvious, that it may seem like I started out trying to do this, but actually that's not how things worked out. Things started in a very different trajectory for me. I guess I grew up in a very similar environment like most of you. In the weekends, when the weather is good, we'd go to the desert, to the bar, and that was maybe some of the best times we had as kids, some of the most memorable memories. I went to a normal high school, just like all of you. I think one of the turning points in my life was when I was admitted to MIT, and there I started kind of discovering, discovering things, and discovering that really, although I was at the top of my class, really at MIT I was just an average student, and I needed to work a lot harder to become outstanding. And at the time, I was really just looking for challenges, scientific research challenges, and so I decided to continue my doctorate because I didn't think about there was a chance to go back to my country, to the kingdom, and to do any kind of research that I would have enjoyed at the time. But luckily, King Abdullah University of Science and Technology opened or was launched right about the time when I was finishing my doctorate. And I was very excited because I thought this was really a nice opportunity for me to try, my chance at giving back to the country that raised me, to the people to the society that I grew up in. And so I signed, and I was very excited that through their generous support, they allowed me to launch my lab. But when you arrive to campus, reality is very different. Everything's under construction, the lab is empty, and here's the empty lab. We want you to make miracles, So, I never had experience building a lab. I had to learn things on the way. Fortunately, I was lucky. I had some good students, and we ended up, through their hard work and we ended up building the lab, but it took us about much longer than I expected. It took 3 years. Actually, I'm sure you guys are familiar with this. You know, things take much longer in this part of the world to be built. Although we get it built in the end, but it takes longer. Unfortunately, when I first started my lab, I had this idea that we're going to use nanoparticles to study, to develop drugs for novel drugs and understand novel biological interactions. But by the time I arrived and the lab was finished, you know, my research plan was developed in 2010, but when my lab was finished was in 2013. And so, if you have to understand how innovation works in any field, if the field is new, if you're one of the first, there's a lot of room to innovate. There's a lot of room for discovery. But as time passes, more people come into the field, and it becomes competitive, and it becomes harder and harder. And that's where we were in 2013. The research plan that I wrote when I first became a faculty essentially expired, was meaningless. And we weren't sure where to go. But actually, a few things things that we did saved us. And it was a matter of choice of our philosophy of the way I approached problems. And I didn't realize it back then, but that's actually what happened. So the first thing was, and I encourage each one of you, is always to be extremely curious, you know, extremely curious. There's nothing, you know, if you see something interesting, drop whatever you're doing and just study it, even if it's not related to what you intended to do the first time. And then the second thing, the second lesson, I think that, you know, we're often, people tell us, you know, as scientists, we're supposed to come up with, we're supposed to answer big questions. But actually, I think it's the other way around. You know, we often encounter answers in our daily lives, and our job is actually to find the right question. Answers are all around us. We just need to find the right question. And like Michelangelo's approach to carving, he sees in every stone, he sees a statue. And it's his job to find the statue in the stone. So I give you it turns out actually most of the discoveries we make in our work, it sounds like, you know, we designed it beforehand, but actually most of the discoveries, in fact, were serendipitous. And it was just basically because we were very curious. I was very curious, and we paid a lot of attention to things. And we took the answers we had, and we tried to find the biggest questions. So here's one small example that actually had a very big impact on our work. I communicate with my students almost 24 hours a day. Some of my students wonder if I ever sleep. I actually do, but I also check my messages all the time. So one night, one of my students, he was trying to grow certain kind of crystals called perovskites, and he discovered something very interesting. He noticed that under certain conditions, normally what would normally take a few weeks to grow, a crystal took a few hours to grow. They started growing in a matter of minutes to hours. And it seemed like a very small thing, except that it turns out this semiconducting material is really important for solar cells, very important for light-emitting diodes, and very important even for X-ray radiation, all kinds of applications. And now we've discovered how to grow it in a few minutes, a few hours, instead of growing in a few weeks. So that changed a lot of things. And then suddenly, I told my students that we have to stop everything we're doing, and we just have to work on this one discovery. Fortunately, it turned out to be, was a big risk, but fortunately it turned out to be the right thing to do. And we jumped on a new curve. We were one of the founders of another field, in perovskites, and we were able to publish a lot of things. And actually, from that point, 2014, where our citations were very low, things started growing in a very nice way. And I would think our decision to pursue unexpected discoveries is the most important, was the most important decision that I've done in my research career. But citations and discoveries are one thing. I think the biggest impact I feel I had are the students that I ended up graduating, and this is the biggest gift you could have on the society. I don't think it's discovering things, to be honest. Discovering that your students can be much better than you, that's probably the most satisfying thing you could find out. So I was fortunate. Many of my students are now also pursuing careers in academia, and I hope one day that some of them will even join Kuwait University. So if I had to summarize the main lesson here is our job. We need to approach life. We need to look at everything as an answer. Everything we see as an answer. We just need to find the right question. And if we do that, I think you'll find yourself being very productive, and you won't run out of ideas in your research. And that's it. I want to thank you. Questions in the end or after? Okay. تفضلوا. I'm open for questions. Yes, go ahead. Yes, right now we don't have any undergraduate programs, although we do take undergraduates from all over the world as internship students. If they want to do their capstone projects in our labs, we do accept them, we do sponsor them, and we do help them finish their capstone projects. Yes.
Okay, so if I'm interested in a PhD program, how can I apply?
So the website is very simple. You can apply. All you need to do is find a faculty who wishes to sponsor your application. Find a faculty whose interests match yours, and write him a very convincing email. And if the faculty likes your application, very likely you will make it to the PhD program.
And it's open all year round, or specific?
So admissions for September is closing soon, or has closed, but for spring it's open. You can apply, but you'll be for spring next year or fall the year after. Yeah.
Last question, I promise. Any GPA requirements?
Any what?
GPA requirements?
Yeah. Yes. I mean, I guess it needs to be a B+ at least. I guess this is what we look for. I mean, but if someone's really outstanding and for some reason they weren't paying attention, or they were sleeping in class, or we could consider that as well.
Okay, great, thank you.
Okay. Thank you. Yes.
Thank you very much for this great speech. I have a question. You obviously took a risk to focus on the small things that turn out to be big. So how would you characterize, or what are the characteristics of things that we should focus on that could lead to something big, like what you did? How would we separate those things that really lead to something big or something small?
Well, I think you need some imagination, and first of all, you need to have experienced a lot of different things to see. When you see some unusual trend, you develop a gut feeling that there's something unusual about it. And then the second question is, second thing you need to think about is try to come up with all the questions that what you have in front of you can answer. And if there's a big question that can potentially be answered, then I think you're looking at something big. Even if it's not a direct link, that you need to jump a few hoops before you reach that. As long as there's a link, that gives you a hint that you're on the right track. So I think the hardest part of the process is actually coming up with all the possible questions. What is the most important question that we could answer by what we've discovered? And I'll tell you something about when we write papers. We write papers as if we kind of design things beforehand, but actually that's a total lie. we actually, what we do is we discover something and we know it's interesting, but then we spend a lot of time thinking about why is it interesting, or why could it be interesting, and that's the hardest part of the process. And then we write a paper, and then we tell you, yeah, we wanted to answer this question, but actually we found the answer before we knew the question. When you write, that's what they tell you. Don't follow a chronological order. That's when you should.
You build a story around the thing that you discovered.
It has to be real. It has to be important. You have to build. You have to build the story. You have to find the story. You have to find the story about what you've discovered. And I think that's the hardest part, is having the imagination to find the story.
Thank you very much.
You're welcome.
ما دام دكتور عفوا
نعم أسف.
ما دام الميكروفون جنبي فخلنا اول شيء دكتور احنا نرحب فيك بجامعه الكويت الحقيقه وفخورين بالانجازات وانجازك هذا احنا كخليجيين ايضا يعني نفخر فيه جميعا وما شاء الله السعوديه قاعد تخطو خطوات مبهره للامانه ونسال الله عز وجل ان يعيننا ايضا ان نلحق بهذا الركب. انا دكتور سؤالي لو اردت لو طلبت منك ان تلخص لي معادله النجاح الاكاديمي البحثي كباحثين، زين، شنو هذه المعادله وشنو الوزن كل عنصر داخل هذه المعادله؟ ان شاء الله ما كان سؤال صعب يعني. انك انا اعتقد انت عندك هالريسبي هذه موجوده ودنا نفهمها بغض النظر حقيقه شنو تخصصاتنا المختلفه، لكن ما هي معادله النجاح هذه؟
الحقيقه اي شخص اسمه عثمان دائما حيسال سؤال صعب. يعني في الحقيقة يعني يعني أولا وأخيرا إنه لازم تكون شخص يتقبل آراء الآخرين، وخاصة آراء الأشخاص اللي يعملون تحت إدارتك، يعني طلبة. كثيرا يعني احنا كمخضرمين يكون لدينا انطباع اننا نعرف كل شيء، لكن ما نلاحظ البديهيات اللي لما يكون الشخص مبتدئ يلاحظها، احنا ما نلاحظ بنفس الاسلوب. ف we have to be يعني open enough to accept that our perspective is not complete, and to accept that the people who work underneath us can really give us very valuable things. And that's the first. This is, I think, the first thing, is to be open to criticism and be ready to change directions, even if it means going 90 degrees or complete different direction. You have to be ready to do that. I think this is the first thing. You have to follow your curiosity. This is the thing. Don't follow don't try to answer. If I started by telling you that I wanted to solve the problem of solar energy, I'm not going to get you the answer. Almost never the problems we wanted to solve are the ones we end up solving. You're going to discover something very different from what you've intended, and your job is to go to your boss or to go to the people working around you and convince them that this is more important than what we started off doing. And that's one of the hardest things is we discover very new things and then that are more important than what our supervisors tell us to do. And so we have to go back and say, you know, we need to change the direction. And as a supervisor, I think your job is to say, to be ready to make that change and to say that, you know, what I proposed at the beginning wasn't the right, it was important, but not as important as what we've discovered. So you have to be ready to change based on your curiosity, based on what, you need to let the science, you need to let the discovery guide you, and not let your initial hypothesis be the one that, you know, a lot of times what I've noticed in students and people is that they want to solve a problem so hard that they discard a lot of interesting observations and they throw it to the side, and then in the end they don't really end up solving the problems in the most optimal way, and they lose really a lot of good stuff that they've thrown out and that could have been big in their careers. Yeah. So, thank you.
Assalamu alaikum. Thank you very much for an excellent presentation. And also thanks to Dr. Haneen for organizing this excellent consortium, I wouldn't say. I have a question. How flexible is your organization to allow you to explore free-handedly? Are you more involved in basic research or applied? That's one question. And the other, if you don't mind, are you relegated to provide any and communicate any of your findings to society, or is community involved in benefiting from any of the research that's produced by KAUST? Thank you so much.
Wonderful. Thank you. Very excellent questions. So one of the nice things about KAUST is that we have two kinds of funding. One is that they give you basic funding. That's, you don't have to write anything for it. That's your basic fund. Any professor has that basic fund. You could use it for anything, any kind of research you want, as long as it's legitimate research. Yeah, you could, and no one's going to ask you any questions about that. So that was very helpful for me, and gives you a lot of freedom to pursue things. But we also have another kind of research that's more competitive, where we have to write proposals, and I think both have very important functions, that you need both, and I think it helped a lot that we had both. But in fact, I'll tell you something, that even when I do write a proposal, and a lot of times most of my proposals that we write, the outcome comes out to be different. And what I found is that the funders, the people who are funding us, they're fine. They're happy with what we've, you know. Yes, we write a proposal about, we're going to give you the most efficient solar cell, but then we end up finding a really new technology for X-ray imaging. We published, that's fine, that's great. So they're happy that we published, we developed technology. They're not going to go back to us and say, wait, what happened to the solar cells you promised us? They were not. They are very flexible, and that requires also some understanding from the funders that otherwise you end up in the situation where we ignore a lot of good science that comes out just for the sake of an initial proposal that never worked out. The proposal that I wrote to my university initially when they hired me was completely different. So if they had to grade me on that proposal, I would probably fail. I would probably, but if they had to grade me as, but thankfully they ended up grading me on my generally on my scientific output and my educational output. Now also, so I think then the next question is, what is our impact on society? I think that's a very important question, and I think initially for the young researchers, they need to focus on developing their science, developing their innovation. For people who are more advanced, and I think in my situation now, we started complete transitioning. How do we apply what we're doing? So a lot of, we moved, a lot of the basics things we built in the first few years has become the foundations to the applied things we did. So now we have X-ray sensors, X-ray imaging detectors that are used, that potentially can provide affordable X-ray imaging technologies to patients and people worldwide at lower X-ray doses, lower energy doses. So that's a big deal. We're developing sensors that can image light that we cannot see, infrared sensors that are affordable, that that can be used in machine learning technologies. So I think focusing on your impact on society, I think that should be the job of the older faculty, the senior faculty. The junior faculty should focus more on developing their science, developing their tool sets, and developing the basic foundations of their work. And once they succeed, I think now then becomes the burden on them to start impacting society. That's it. Thank you.
First of all, I'm Mashal Hamli. I'm a faculty member at the English department. First, let me thank you for such an inspirational talk and to welcome you to Kuwait University. And you almost answered my initial question, which was about research grants, proposals, and telling our students how they need to be focused on what they started initially on doing. I do understand that sometimes interesting findings come along the way when you least expect them. But at the same time, I want to have your opinion concerning there are structures, there are systems. If you ask for a research grant, then you're expected to deliver what you promised to do. And then if you write a research proposal, let's say for an MA thesis or a PhD thesis, then you need to stick to the same title, to the same research questions you started with, especially when it comes to the humanities. I know you come from the sciences, but I'd like to have your opinion on this, if I may. Thank you.
So I remember when I gave my thesis proposal. And so thesis proposal is the exam you need to give in order to be formally a PhD student, and to be. So the moment I finished my proposal, my advisor, I passed. My advisor said, "Congratulations! Now you could do whatever you want." So actually, it's I don't in most places in the U.S. and at least in the world, your thesis proposal is just to show that you're competent enough to understand the basic science, and you're competent enough to handle any unexpected questions, and you understand the scientific process. But actually, you're not expected to follow it. In fact, many times you're not. If you followed it, then it was obvious to begin with. That's what at least a lot of people think. It's like if it was obvious to begin with, you just maybe we shouldn't have spent so many years trying to flesh it out. So I think we should accept that what we propose in the beginning might not be what we end up doing. The proposal, the purpose of the proposal, I think, from a graduate perspective, should be to test the competence of the student, test his understanding of logic, his understanding of the scientific process, and test certain aspects of them, and make sure they have the tool sets to wander off. And of course, as students, we have to do things that are related to what our advisor is doing. I can't, I can't propose a question in material science and then start working on, English literature, for example. That's not gonna. No one's gonna pass me for that. It needs to be in the same field. It needs to be, of course, generally, and we are constrained by our funders. So we try to at least do enough to please our funders, but also but keep the rest to please our curiosity. So, and sometimes we sometimes we realize that our funders just need to know this much in order to keep funding us, and we keep the good stuff for other things. So I think it's fine. I think there is some constraint that we should live with, but we should accept that if we want to succeed, if we want to have a really graduated students who are going to be outstanding independent researchers, we have to accept that they will not follow the path that we initially set them on. We just need to make sure, our job as advisors, we advise, not to force them to do things, but just tell them, kind of guide them, help them navigate the path till they find something big. Yeah.
دكتور بعد إذنك بس عندنا آخر سؤال.
Ahmed Saeed, Professor of Ancient History and Archaeology, Near East. First of all, many thanks for this very, very interesting lecture. Really, I want to ask about this statue, which it's come to 14 or 15 or 15 century. Really, I need more information how to use this statue in your project.
Okay, so
thank you.
Sorry, the statue. I'm not okay. Thank you, doctor. I'm not an archaeologist, and I don't know. Maybe I go to museums and read a few books, but I'm not an archaeologist. So that was a statue was kind of a metaphor. When Michelangelo, when he started sculpting things, he didn't design his sculpture. He designed his sculpture based on the stone he was given. So he didn't know what he was going to design. But he looked at the stone. He looks at each stone, and says, "Well, this is what I'm going to do in this stone. This is what it looks like could fit here, or this is the image that I could carve out." And he didn't say that I'm going to carve out an image from whatever stone he got. So that was the message that I was trying to say is that in life you're given stones, and you have to make the best out of them. Thank you. شكرا جزيلا.
Thank you very much, Professor. To be notified, these two sessions, morning sessions, are in English, but the rest will be in Arabic. She's an acting chairman of physics department and leader of Kuwaitsat 1 project. And once we mention Kuwaitsat 1, I would love to give a huge shout out for our Kuwaitsat 1 team over here. A big round of applause, please. Dr. Hala Khalid Al-Jassar is specialized in space physics and is an associate professor at the physics department of Kuwait University. She obtained her PhD from University of London, UCL, at Mullard Space Science Laboratory, MSSL. She is the leader of the Space and Climate Physics Research Group at Kuwait University. During the last 28 years, she established the satellite remote sensing laboratories in the physics department and developed bachelor's undergraduate degree in engineering physics satellite remote sensing at the physics department, Kuwait University. She was the PI and the co-PI and the co-I of around 17 projects granted by Kuwait University, KU, Kuwait Foundation for Advanced Science, KFAS, Kuwait Oil Company, KOC. She is now the PI of Kuwaitsat 1 project Al-Jassar had 2 KFAS prizes for the best research papers. The first prize was in 2006 and the second prize was in 2012. Please welcome Dr. Ahal Al-Jassar.
Bismillah ar-Rahman ar-Rahim. First, let me thank Kuwait University for inviting me to give a brief and overview for Kuwait Sat-1 project. I will try actually to focus on the timeline that actually we started, in which we started this project around more than 3 years ago. So, space. Why space? Actually, space is it's an inspiring subject for everyone, especially the youth. Space actually, it inspires, you know, the youth for STEM studies, science, technology, engineering, and mathematics. This is a subject that actually it is important for Kuwait that we should encourage our youth to go over these studies, and we should start, you know. Most of the countries around the region already, they started this, basically space programs. And space is the future. Everything depends on space, as you can see as we go over the slides. So actually, let me just tell you something. This is a quotation from John Glenn, who he is American astronaut who lived between 1921 until 2016. He is the first American to orbit the Earth 3 times. He's not the first astronaut in the States, but he is the first American to orbit the Earth at that time. The first astronaut in the States was Alan Shepard. Actually, that was in '61. So this is a quotation that actually for inspiration for STEM studies for the youth. I will go over an overview just to give you a brief introduction, vision, mission, objectives for our basically capacity building project. Then I will go over Kuwait Sat-1 mission track, and then focusing on the learning capacity building. Of course, this is a capacity building project. It's not a research. Mainly, this is a pilot project funded totally by KFAS, and we thank KFAS for funding the project. It is a pilot project to train our youth, you know, the young men and women in Kuwait. So, as I said, actually, the project, we started this project in proposing, you know, our basically document to KFAS in 2018. They considered this as a pilot, it's not a research, to train students. And it went over external reviews until we got the acceptance from KFAS, and the project was kicked off in 2019 in October exactly. We had the first announcement that was in the summer 2019. More than 200 young men and women from Kuwait, they applied for this project. Mainly they are from Kuwait University, and we had graduate students from Kuwait University, and also we have fresh graduates as well. The project actually, as I said, it is meant for motivation. Motivation is very important. Inspiring the young people is very important. Also, as I will tell you later on, the main objective is training, and as well as building, you know, the infrastructure at Kuwait University, like starting with a space lab, then we can grow on for future space project. The long run objective is to start the space domain in Kuwait. So our mission is establishing the space domain in Kuwait. The vision, which we actually hold it every time we meet with the student, it is build, succeed, and explore. We have primary objectives and we have secondary objectives. The primary objective is to have a successful launch. Alhamdulillah, we had the successful launch. Okay, and most of you have observed this launch on the 3rd of January. And the operation of this satellite, alhamdulillah, we are now at the end of LEOP phase, which is the launch operational phase to test all the subsystems of the satellite. And all the subsystems, they are working well. We received the signal just like 3 days after the launch. Actually, we expected like after 4 hours, but because the SpaceX Transporter 6, they launched like 114 satellites. So there were like a conjunction. There were like, this orbit was very busy with the small satellites. So we waited until the satellite, they got far away from each other to get the first signal. Alhamdulillah, we got the first signal, and we are communicating very well with the satellite. All the subsystems, they were basically tested. They are working very well, including the payload, the camera. The camera is working. We got images also from the camera. But actually, unfortunately, in the last 3 weeks, as you can see, every day is cloudy. So all the images are clouds. Otherwise, I will show you, you know, the image for Kuwait. But hopefully, inshallah, soon we will get the images. Of course, one of other scientific objects is to investigate the feasibility of using the camera as ADCS, which is the attitude determination for the satellite. Although we have other techniques using, you know, like reaction wheels or the magnetometer or the sun sensor to orient the satellite, but this is a good basically exercise for the students, which we added as a scientific objective. The secondary objectives for the Kuwait Sat-1 is to develop the university capabilities in nano-satellite. And what do we mean by capability here? We mean the ability to design independently a complete nanosystem, a nanosatellite mission, and this is actually measured by the documentation which is produced through the design. Because it is the first, Kuwait Sat-1 is the first mission, so everyone is learning, even us, you know, in the team, we are learning basically the design and the testing and the integration and all these things. Of course, let me tell you something. This project is a collaboration project, although it was initiated by us in the physics department, but we couldn't do it alone. It's a collaboration with the engineering department, different engineering departments, like we have the electrical engineering, Dr. Yasser Abdurrahim, who is joining us here. We have also the mechanical engineer, civil engineer, together with other departments in the science. We have also a government sector who actually collaborating with us. We have actually CETRA. CETRA, basically this is the actually the main part for registering our satellite, and they help us in registering the satellite with the ITU. We have also EPA and KISR. And we hope that once we get the images, we will find vital application, important applications for Kuwait. So the team. We had the first announcement for the team that was, as I told you, in the summer of 2019, in which more than 200 applicants we got from different diversity. Then we had the second announcement for the 2nd wave, and that was by the end of 2021, we got also more than 100 applicants, in which from these two different waves, we selected the cream of the cream in Kuwait. I say the cream of the cream because they are really talented applicants. And now we are about 45, in which we went into a program to train them. And yet, as you can see, it is a diversity. So we have most of the students from engineering, but also we have from the science. I will show you now the statistics. And we have some from other disciplines, neither science, neither engineering. So space includes everyone. This is actually, if you want to do a serious space program, you need to include even law studies, even economy, people who are, with a background in space economy, background in space law. All these actually, once you start the serious space program, which I mean that hopefully we have it near in the future here in Kuwait, we know diversity is important. So this is the statistics about the team from the 45 members, 51 engineering and 42 from the science. We have 7% from other disciplines. Okay, so this is the diversity which we are talking about, the collaboration, which is most important in big projects like the space. And now, these students actually, they started with us in 2019, but many of them, they graduated, but they are still with us, and they are still here with us, although they are working now in government sectors or in private sectors, but they are still working as a volunteers. And that shows how much this actually momentum that they have. And even our visitor from University of Colorado, when he came here at Kuwait University to give a workshop, Professor Albin from Boulder, he said, well, it's amazing. We don't have this in the States. So I told him, because this is the first project in space. And this is very, we consider it as an inspiring project. And he said, this is amazing. Anyway, so the undergraduates is 18%. Postgraduate who finish their studies with master, 18%, and who are currently studying masters, 11%. So also there is a diversity in the degrees. In gender, well, because in Kuwait University, as you know, majority are females, so here we have 69% female, and we are proud of them. They are from engineering department, science department, so, and they are very talented. With a male, 31%. We encourage more male, of course. We like to have it like 50%, 50% as equality, but actually this is the percentage that we have. So the 45 members that we have them in the Kuwait Sat1 team to organize actually the work, because in space you need to do different stuff here and there and different tasks. So we had 3 teams. The first team, which is very important, the technical team. These are responsible for the satellite, starting from the design until the testing and the launch. And also they are responsible for the ground station, because we have a ground station which was built in the North Building, at the Science Building, which has 2 antennas, UHF and S-band. These basically 2 antennas are important for satellite communication and getting the data. The technical team, as I will tell you what they will do later on, we have also the application team and we have the control team. So the technical team, I don't know why it is like this, but the technical team, they started from the beginning working. We had 2 parallel lines. We have the real satellite mission, because we don't want to do a risk actually. And we have the track of the student, which worked parallel with the track of the satellite, like starting from the design, testing, integration, and then the launch. But we tried actually to work these 2 lines together. So the student, they worked on the real satellite as a space project, starting from the preliminary design review, PDR, then the critical design review, then until the FRR. And they had to do the documentation, they had to do the seminars to show us that they have learned over these three different basically tracks, phases for the satellite. And they went also over different courses for the know-how of the subsystems, like the payload and the power and all this stuff which are related to the Kuwait Sat-1 subsystem. Also now they are working, because we have the satellite launch, so now they are working actually 24 hours, especially in the LEO phase, operating for this satellite, looking at basically the commands every day, transmitting also the signals, and alhamdulillah, we are now getting the images. Also maintaining the ground station. We had a problem with the rotator for the S-band, and we contacted actually our people who are working, we are working with Nano Avionics in Europe. Within like few days we got it on DHL, the rotator, and amazing, it was 100% replaced by the technical team, and we are really proud of them. They did this within like 24 hours and they replace it. So they're doing very well also with the maintenance and also with looking at the software and other things. Now, the application team, they are responsible for archiving the images, download after the technical team, provide them the image after download, and also they have to do the job of image processing and writing small codes if we need more information or certain information from the images, depending on the application. They have also to work close with the researchers and other users, either from KISR or from APA or from Kuwait University, of course. The control team, I think they are centered. These are the members that really we depend on. And I thank them really very much because they did a great job in managing and helping other teams. And they are managing all the official accounts, shooting the videos, photograph, managing and organizing workshops, conferences, lectures, exhibitions, like the one that we have here. If you go to the exhibition area, you will find our team there. And without them, we cannot actually go on the timeline that is designed for this. So this is the mission track for Kuwait Sat-1. We started, as I told you, in October 2019, and we started with the preliminary design, PDR. I will show you more detail, time track later on, but this is just like a summary. Of course, this PDR, before PDR, we have to do the mission statement, objective, because designing depends on what you want. So that took some time. Then we had after that, the critical design review, in which so much documentation has to be done here, the CDR. And then the last thing, which is the FRR, the flight readiness review. The launch after the testing, in which we send some of our technical students to Europe, because of course we don't have an infrastructure. We are starting some infrastructure. And alhamdulillah, now we had the ground station built at Kuwait University in the North Building. And we have the FlatSat, which is a copy of Kuwait Sat-1, but it is an open satellite, right, in which the student, they write small codes and they train on different subsystems. But we're still because having the full infrastructure for Space Lab, it needs quite a huge budget, but it takes time as well. So the students, they went for the last, actually, testing in the summer, last summer. That included the FRR. And the satellite, it was ready to go to orbit from July. But actually, because of the delays that we had with the SpaceX, especially SpaceX, they have a big program on Starlink. If you heard about these Starlink satellites, that every week they launch about 50, 40 Starlink satellites for mainly for internet communication. They kept like delaying not only our satellites, many other actually satellites from different users. They were delayed until we had it, alhamdulillah, in January. So this is the detail of the Kuwait Sat-1 timeline. Of course, we started in 2019, but we took some time, like doing all these contracts, collaboration contract with our international partner, University of Colorado at Boulder. And we have also another contract that we did it through the research department at Kuwait University with Mohammed bin Rashid Space Center. We sent our student for a training that was before Corona for 2 weeks. We also took some time in the procurement of CubeSat component, and really I want to thank the administration here at Kuwait University, you know, that they made this basically national project easy to go over this procurement case, although it takes some time, or it took some time, but alhamdulillah, yani, we had alhamdulillah, yani, we had the help from everyone. The procurement of the FlatSat, which is a copy of Kuwait Sat-1, which is in orbit. It is in our labs at the physics department, and the students actually they use it for training and writing codes. Of course, we had already the now the ground station built and installed last October, and is working, alhamdulillah. The system design, the PDR, CDR, FRR, as you can see, it took, as on the schedule, it took the right time, so we didn't have any delay. Regarding the capacity building, because this is the main objective for our project, capacity building, we started from the beginning with wave 1, wave 2, and by the way, we, on the 28th of February, we had the third announcement for the third wave for anyone who want to, and it's going to be for the students, undergraduate, the senior undergraduate or postgraduate, or the fresh graduates to apply for that project. The deadline will be on the 24th of March. The launch phase or the post-launch phase, of course, from the beginning of our project, we had to communicate with CETRA, and we had also to communicate with our representative in Vienna, okay, to register the satellite with the UNUSA. And alhamdulillah, the letters went, and now registration is done. Also with the ITU, it is registered, because you cannot launch the satellite without doing all this registration for the frequencies. Now, regarding, yes.
بس بعد اذنك.
Yes. Time.
انا اللي قاعد اشوفه هو ما بين imaginary وما بين engineers. ف imagineers اذا جمعناهم مع بعض انا وايد احبكم والله يوفقكم، بس ودنا نسمع ايضا اسئله من الساده الحضور اذا ممكن.
Okay. بس خليني
بس علشان too short.
Yes, I will go quickly.
Inshallah. Okay.
So I told you about BTR, the CDR. I'm not going to go into details. FRR. Now the capacity building. I'm almost finished. رح أخلص إن شاء الله. لا تحاتي. So we had many workshops, seminars, webinars, conferences for covering this capacity building. The capacity building actually it involved building the knowledge and the skills, and also integrating the knowledge, and after we trained the wave one, actually they helped us also to train wave two, and we have internal or in-house training, and we have external house training. So we went over all these different basically training workshops and training basically courses. We actually, let me just skip these things, in-house training. Also we had visitor from University of Colorado to give us a training here at Kuwait University. This is the flat sat which I told you about. And this is during Dr. Professor Alban Kauziski from University of Colorado. He gave our students a training workshop at Kuwait University. And all these images, as you can see, it involved. This is during the external training. This is during the FRR, the Flight Readiness Review, in which the students, they went to Europe to actually to attend the final training. Also, this is from UAA in BRC. And inshallah, this summer, KFAS, they are funding our students for 2 weeks training in the space labs at University of Colorado. Then our students, they will attend the small satellite conference. And the next April, inshallah, Shahr al-Yai, they will attend another COSPER. COSPER is the biggest space organization, in which this is also funded by KFAS. So imagine all the satellites around the orbit, they will stop. What will happen? From University of Texas, Austin, a space scientist and aerospace engineer. Actually, he did like a study and Moribaja, and he said like, if all the satellites stop suddenly for some reason, within hours, most of the planet traffic would grind, the world economy, it will shut down. Imagine how much we depend on this. And most of the countries, they will declare a state of emergency. Everything that we are using in our daily life depend on, satellite. So, is it only for luxury, the space? No, it's not only for luxury. Space is very important. There is something called space economy. And based on Morgan Stanley study, that was in 2020, they estimated roughly that the renovation, it will go up from $350 billion, which is in 2020, to $1 trillion by 2040. So space economy is taking part, a great part in space economy, and it is considered very important. So thank you very much, and I want to thank KFAS for sponsoring this project, 100%. Also, I want to thank Kuwait University for their continuous support. Without this continuous support, actually we could not reach today and give you this lecture, and we could not have the launch of our Kuwait Sat-1. Thank you very much.
Thank you very much دكتورة هالة. ممكن تسموني قاتل اللحظات السعيدة، ولكن هذا دوري للأسف. Thank you very much دكتورة. الله يعطيكم العافية. أي أحد عنده سؤال يقدر يتفضل ويسأل الدكتورة مباشرة، لأن الحين دخلنا على فترة الغداء بالعافية مقدما، ولكن اللي عنده سؤال أكيد يقدر يتوجه للدكتورة هالة ويسألها مباشرة، أو على الغداء، بس يعني اتفضلوا.